Hello everyone, welcome once again to our session. Today we are going to continue our discussion on the solvable groups of trigonometric integrals. So still we are going to focus our discussion on group 2. So those integrals of the form as you can see in this slide. So same condition, m and or n are positive integers. So last time we solved example for case 1. Okay, so today we are going to solve example for case 2. So in case 2, we have to take note on this concept that when n is even, when n is even, so and n is greater than 2, then we need to factor out secant squared du and replace the remaining secant by tangent using this identity. Trigonometric identity is secant squared u equal to tangent squared u plus 1. Okay, so for example, so we're given this problem. So I will show you once again the step-by-step process of solving this problem. Alright, so we are given this example. We're given the integral of tangent cube x secant to the fourth x dx. Okay, so as mentioned, we are now in case 2. So what is case 2? So case 2 when n is even, and greater than 2, right? N is even and greater than 2. So if that is the case, then we need to factor out. So we have to factor out secant squared u du. Okay? And after that, we have to replace, or we have to change or replace. So we have to change or replace secant. Change this or replace this by tangent. And to do that, we need to use the trigonometric identities secant squared u equal to tangent squared u plus 1. Okay, so we have to make use of this identity. Okay, so to continue, so I will rewrite this. So I put the equal sign here. So this can be written as integral of, we can write so we can replace, or we can write the same for tangent. So tangent cube x, then we have to break secant to the fourth, into two factors, secant squared x and secant squared x, then dx. Okay, then after that, we have to change one of the secant squared into, or in terms of tangent, because the rule here is you have to factor out, right? You factor out secant squared du. So we have already this one, so we have no problem with this, so we have to factor that out. Then next we have to change secant to tangent. So this secant here is the remaining secant. We have to convert that or change that into tangent using this identity. Okay, so we can rewrite this as integral of tangent cube x, then rewrite this secant squared in terms of tangent, so this can be written as tangent squared x plus 1 and multiplied by this secant squared x dx. Then after that one, so we need to distribute and multiply. So it means that we have to multiply this tangent cube to the first term together with this. Okay, and we also have to do that for the second term. So this one together with this. Okay, so looking at the red arrows, so this is integral of, so tangent cube, you have tangent squared, so that becomes tangent to the 5th power x multiplied by this part, secant squared x dx, then plus, because this is plus, so tangent cube x multiplied by 1 multiplied by secant squared x dx. So this becomes integral of tangent cube x secant squared x dx. Okay, so if you can still remember from our, again from differential calculus, if you have derivative of tangent u with respect to u, this is equal to secant squared u, right? Then multiplied both sides by du, or cross multiply du, so we will have the differential of tangent u is equal to secant squared u du. Okay, so we are going to use that formula. So we have already here this part, secant squared x dx. We also have here secant squared x dx. Okay, it is in the form of secant squared u du, and that is the differential of, or we can say that is our du. Okay, so we can let here we have our n equal to 5, then here our n is equal to 3. Okay, and then we can let tangent x be equal to our u, or let u equal to tangent x. Then du, I'll just write it directly, class. So du, following this formula, So this is RU is tangent U. So derivative of U or differential of U is equal to, for tangent, that is secant squared U du. Okay, so we can follow that one. So we can have our du as secant squared x dx. Okay, and the same, no, for this term, RU is also equal to tangent x. So therefore our du is equal to secant squared x dx. So to continue, so substituting, so the equation now becomes integral of, instead of tangent, we let tangent x equal to u, so we can write this as integral of u and n, u to the n, which is equal to 5. Then the whole thing here, secant squared x dx, secant squared x dx, that is our du. So multiply this by du. Okay, then plus this part here, that is integral of, again, that is also u. Our tangent x here is equal to u. Then the exponent is 3. Then times this secant squared x dx. Secant squared x dx is just equal to du. So times du. So if you look at the result, so that is in the form of power. So we can use power rule. Okay, so using the power rule for our integration, so we have u to, so this will be u to the n plus 1. So this is u to the 6 divided by 6, then plus u to the 4th power divided by 4, then plus c. Okay, or this is equal to 1 over 6 u to the 6, then plus 1/4 u to the 4th plus c. Then substituting the value of u, or u is equal to tangent x, so we can rewrite this as 1 over 6 times tangent x to the power 6 plus 1/4 tangent x to the power 4 plus c. Or this is also equal to 1 over 6 tangent x to the 6th power plus 1/4 tangent x to the 4th power plus c. So that's our final answer. Okay, so I hope you were able to follow the process class. Thank you, and see you again in our next video. So bye.